Good morning and welcome to the APCO check valve webinar training this morning.
Check valves are a very broad topic, and we will only cover a few of the basics, including the purpose of check valves, selection considerations, and common types that we offer. We will spend some extra time on one common application concern, check valve slamming. We offer more check valves, but we don't have time to cover them all today. Notably, Hilton fabricates a number of check valves that are custom designed for specific applications. The valves we are to discuss are very simple mechanical devices. They open when the upstream pressure exceeds the downstream pressure. Usually that's a fraction of a PSI, a quarter PSI, maybe up to a half PSI. When the upstream pressure exceeds the downstream pressure, then the valve will open. They'll remain open because there's flow velocity. When the flow stops, a check valve closes. Check valves are critical for pumping systems. When the check valve is closed, it keeps the valve that was just pumped, keeps the water that was just pumped out from returning, preventing the well that was just emptied from flooding. Also, check valves prevent pumps from backspinning, a potentially costly and disastrous event. Check valves can keep pipelines full. That's one of their purposes. When the pump starts up, it can be a problem when pumping at full capacity into an empty pipe. Surge events can occur, air vac valves can slam, and so on. Like so many valves, there's often more than one right solution. It's our job to point out options to our customers and steer them to the best ones. Our valve selection guide is an excellent resource to get you started. There's a selection guide starting on page 33 of that bulletin. We have to consider what is being pumped through the valve. Is it dirty water, clean water, abrasive slurry, air, something else? Are there application conditions that could cause check valves to slam? The amount of leakage allowed will affect what type of seat is required and which valves have those seats. Purchase price isn't the only consideration, but also if they're energy efficient and how long will they last. On the next couple slides, we will discuss media type and cost of ownership. Both swing check and rubber flapper check valves are good choices when the media is dirty, such as wastewater and slurries. When they open, the disc or flapper moves aside to let the media flow through the valve with minimal disturbance. Because they move out of the way, lumpy and stringy things won't get caught in the valve, preventing it from closing. We even have options to deal with abrasive slurries, and we'll discuss that a little bit later. Generally speaking, all check valves, like the ones shown here and the ones that are good for dirty media, are suitable for clean media applications as well. However, some check valves can only be used with clean media. They all have something in common. There's part of the valve in the middle of the flow stream and could cause them to foul up on dirty media. Each valve excels for their own reasons. These could be purchase price, available space, materials of construction, quick closure, energy losses, and so on. We'll now take a look at the high-level view of cost of ownership. While there may be more than one type of valve that can do the job, the cost of ownership should be a consideration. Combined cost of purchase price, installation cost, maintenance cost, energy cost, and other costs. This slide deals with the purchase price or capital cost and energy cost or operating cost. The left side of the screen has the highest cost and decreases as we move to the right. Our premium swing check valve, the CVS 6000, is generally the most expensive. It's the heaviest duty and is a problem solver because of its multiple options. Sliding disc check valves are also expensive, as they can be equipped with any number of options to suit the application requirements. Those valves are highly specifiable and can be strategically important. As you move to the right, the valves tend to become more general duty, including the CVS 6000 and rubber flapper. On the far right, silent check and double door check valves. Operating costs can be expressed as how much does the valve contribute to the cost of pumping. As you can see, the one of the least expensive valves, which is the silent check valve, can be the most expensive when you factor in the energy losses through the valve. Likewise, if you look at the sliding disc check valve, one of the most expensive valves is actually the cheapest and can save energy in the long run. Now we're going to take a look at some check valves. So we're going to switch over to the camera mode. So one moment, please. All right. The first valves we're going to look at are the silent check valves, and we're showing two different types on the screen there. There's a wafer style, which is what we call the CSC 300 silent check valve, 300 style body, available in sizes 1 through 10 inch, and on the right-hand side of the screen is the globe style, which is the 600 size body, and that's available all the way up from 3 inch all the way up to 42 inches in size. Silent check valves got their name because they close quickly before flow reversal and don't slam. Usually, that's the intent of the design. Low flow, high pressure systems take advantage of this type of valve. A fire protection system in a high-rise building would be a good example. They pump water from the ground hydrants up to high floors. The vertical piping and high pressure can cause very quick flow reversals.
As you can see here, these valves are very similar in components as far as we have a seat, the disc, the spring, and the body. The bodies are really the only differentiation between these two valve styles. These valves are offered in both metal seated and rubber seated. If there's a rubber seat, this is a metal seated, but if it was rubber seated, this would be sitting on this surface right here on the body seat. And we offer that as standard in NBR. It is also available in EPDM and Viton. As you can see, this is a clean water valve because of the disc always being in the flow path, and it says high head loss because it only opens about a 1/4 inch of the valve diameter itself. The spare parts really on this valve would be the seat, and that is really it. When you're installing this valve, take a look at the instruction manual because there are some special considerations to take into effect when you are putting this valve into the pipeline. Mainly, it is going to be dealing with the inside diameter of your pipe to make sure we restrain this seat and that it doesn't have some kind of failure going downstream.
We're going to next take a look at the rubber flapper check, or I'm sorry, the silent the double door check valve. We manufacture that valve in sizes 2 inches through 60 inches in size. Actually, the valve is an option when space is limited or a purchasing budget is small. It can be prone to slamming in more difficult applications.
The double door check valve, obviously by the name here, has two different doors for the closure devices. Has a spring here to help assist in the closing. We have a hinge pin, the stop pin, and the body here itself. This valve is available in a wide variety of materials. If we have corrosion or different chemical issues and stuff. The valve is also available in both a metal seat and a rubber seat. This one here is shown, turn that back a little bit. It was the rubber seat right there, the black. It is molded into the valve body, and that is standard in NBR, but we can do EPDM and FKM. One note about this valve is it's common also in blower applications where the media is going to be air. If you know what's in that application, we'd want to know this to use actually a different spring. We'd want to use a lower torsion spring to make sure the doors open fully with the lower pressure of air. If this valve does not open fully, what can happen is it will get to a midpoint, and actually these doors can flutter then if they're not open fully all the way. And then we have issues of doors failing and stop pins also, or hinge pins also failing because of the fluttering action that the valves can get. And you can actually sometimes get a chattering if the valves are going like this, if the valve's not opening like it is intended. This check valve is intended to open fully to be used best.
And it's our general rule of thumb that 5 feet per second of fluid velocity was adequate to open it all the way.
Yep.
Okay, good. Both double door and silent check valves are common styles without a lot of options. The next valves have more options and can solve more applications, and we were able to write strategic specifications for them. Oops. So we're going to look at the CRF rubber flapper check valve, available in sizes up to 24 inches in diameter, and it's such a simple design. They're versatile, they're good for all types of media. They're simple, but they can still be configured with a number of specifiable options.
This valve is as you can see right here, this is actually the seat angle that is inside the valve body. So this valve is a very quick opening and also quick closing check valve to help reduce, to close quickly on flow reversal, so we help limit any slam issues possibly. It's a very simple valve in the amount of parts that it actually has in the valve itself. We have our cover, we have the valve body itself, and we have the flapper. This is really it for the components in the main standard body style. The flapper is standard in NBR, but we offer it in EPDM and also Viton for different applications. We can take a look at actually a cutaway of the flapper here. Hopefully you can see that, there we go. And if you look at this, the flapper has a impregnated inside of it, encapsulated with the inside the rubber, is a metal disc right here to help give the disc its rigidity to help seal against pressure in the valve body. Up here is a pin, then that's the part that is clamped between the valve body and the valve cover to help keep the flapper in place. And also, if you can see it, I think you can see it a little bit, you see some little lines in there, it is wire mesh, and that mesh helps to give reinforcement to the flex point. Because that is the part, when it's sitting in the valve body, is going to be opening, closing, it's going to be flexing there, and that wire reinforcement, that is what's going to give it its strength so you can get the cycle life out of the valve itself. Included as standard is an internal leaf spring to assist in closing prior to flow reversal. We're going to show you another option here. This valve has some options that we can do for different applications. And one of the things we commonly do is we rubber line this valve. Because it is so simple with just the body and the cover, get you halfway decent look here, here we go. We can fully rubber line this body because it just entails rubber lining the body and then the cover itself. This is an option that works very nice if you have any kind of abrasion issues. Mining is a very typical one where this has happened, but anything in general where you're going to have some abrasion issues, we can rubber line this valve completely like we do on our plug valves. Standard is NBR, we also do natural rubber, EPDM, and we can do Viton also. On this particular model also, we have the hold open device feature. Really what it is at the bottom of the valve, we put a jack screw, and as you can see as we screw that out, it will push the flapper up open into the flow path. This is for when someone is wanting to use this to drain a pipeline and stuff, even though there'll be pressure onto the flapper itself, they can screw this out, pushing the disc open, and then letting the flow go back into the pipe, or on the other side of the check valve for draining purposes.
Just some things to think about when you're selecting rubber flapper check valves, that we have multiple body styles. First of all, it's the model 100A body, which is the cost-effective version of the basic rubber flapper check valve. We also have the traditional APCO style 100 body, which can be equipped with a number of features, which we'll discuss a little bit later, but it could be bottom-mounted buffer, spring assist, spring return, and so forth. The one thing to note as you're selling these valves is that the traditional APCO Model 100 has a pressure rating capability of 175 psi, whereas the 100A has a capability of 250 psi. Okay. So now we're going to go to the slanting disc check valve. I guess I should mention the most expensive operating cost in a pumping system is electricity, especially when it's a high service pump that runs all the time, 24/7. Electricity can be a major expense. Slanting disc check valves are the most energy efficient style of check valve available and is commonly used in those type of pump stations. Because of their energy savings, the high cost of slanting disc check valves can pay back in a short time, perhaps only a year or two, even though they're expensive to purchase.
The slanting disc gets obviously its name, but by looking at the angle that the disc is sitting at. You'll also see sometimes these referred to as tilting disc check valves in specs. And the reason that it sits at this angle is these pins are in a position where this is its natural sitting position and opens very, very easily with very little pressure, and it's held open with very low flows. Another reason that it stays open with low flows is the design of the disc itself. It is designed like an airplane wing in a sense, where there is a curved top with a flat bottom, so the flow over the top of the disc is faster. If you have a faster flow, you have a lower pressure. Lower pressure on the top compared to the bottom means the disc will open easily and with lower flows. This valve has two body halves. We have body half here and another one here. We have our body seat ring that is actually wedged in between the two body halves when it is bolted together. You have your disc. Also, you can see in there we go, we have our disc pins. There's two of them, one up over here and the one right there. These disc pins have a machine tolerance in them that when this valve closes, it actually, there's a machine tolerance that lets the disc then kind of seat into place to help this check valve seal off tighter for a metal seated valve. This valve is only offered as a metal seated. There is no rubber seated option. So with that machine, that tolerance into those pins, it allows us to get a good, a tighter shut off for a metal seated valve.
One of the things about this valve is it's capable of being accessorized in a number of ways. A bottom mounted buffer is one option. I mentioned we'll talk about that in more detail in a little bit. To prevent slamming, and also a top mounted dash pot is a common option which can control the rate at which the valve opens and closes. We're going to talk for a minute about the, maybe more than a minute, on the swing style check valves. And it's by far our most common type of a valve that we sell, arguably the most common valve in our industry. And, you know, we're going to, I guess, show you a few things about it. So I'll just mention that the one that we're showing is the APCO, the CDS 6000 series of swing check valve. It's our premium valve in the industry. It's got the most versatility that you'll see with accessorizing and options. It's the heaviest construction, arguably the most expensive check valve out there, but once again, you get the return on the solutions it provides. The valves are available in sizes from 2 inches through 66 inches, and with a number of materials with pressure capability all the way up to 640 PSI.
This is our 6000 series. Talk about a few of the different features from this to our more standard check valves. But I have the cover removed here so you can see inside the top of the check valve in a sense to see the internal components. So normally you'd have a cover here. It's our body. This is our pivot pin, shaft seal cover. You have your disc is in here. This is a single piece disc and disc arm, which is a stronger, more reliable connection than an articulated single pin connection. It eliminates common failures like disc misalignment, pin wear, and loose pin connections. This also has a larger pivot shaft compared to our standard check valve. And if I turn this here, you can see we also have very large bushings here to help with any kind of bearing stresses and stuff for the larger, higher applications that this check valve is used for. You can see into that well. There. Right in here, we have the stainless steel part in the body. That is our body seat. That is normally out of stainless steel. We can also do it out of brass, I believe. And inside here, we have a rubber seat that sits against our body seat. The rubber seat is on the disc, and this ring right here with the bolts in it, that is what is holding the disc seat onto the disc itself. This is one of the main components that is replaced in the field. If you're getting leakage, you would want to look at replacing this disc seat. And standard is NBR. We also offer in EPDM and FKM.
When a swing check valve, when a check valve is in a service where the flow reversal is moderate, you can normally prevent slamming by closing the valve quicker than the flow reversal. Think of a door being open and the wind catches it. You know, if there's no wind, you can pull the door closed and it just closes nicely. But if there's a wind behind the door and it pushes the door, it could slam into the door jamb. Think about that with water instead, which has a lot more density, causes a lot more energy, has a lot more energy. And so you want to close a valve after the pump turns off. The flow is velocity will decay eventually to a stop, and then it will reverse. You'd like the valve to close before the flow reverses, and if you can. So we're going to show you a couple of our types of means of doing that on the swing check valves. And the first one you can see right here is the lever and spring design. So the valve could close quickly just by the weight of the disc, but it might not be quick enough. So it's very common to influence it or accelerate the closure with a closing device, such as a spring, like you see here. The idea with this, as the valve opens, the flow will push the valve open, pulling on the arm, stretching the spring. The greater the length that the spring is stretched, the greater the force acting on the disc. Like I said earlier, as long as there's flow, the disc will remain open, but it will remain open with some resistance on it because the spring is trying to pull it down. When the flow stops, the spring takes over, the stored energy takes over, and it will close the valve quicker. You have some ability to adjust the spring. On this particular one, there's a adjustable stop bolt that you can shorten it or lengthen it. On some of the larger valves, there's even multiple holes on the lever where you could hook the spring into for different leverage amounts. So that's it on the spring. Let's go with the lever and weight now. All right. And the lever and weight is more common. The further open the spring, the valve is, the more force the spring is exerting on the disc, and it causes some greater head loss. Whereas when you do a lever and weight, like you see here, now this one's shown with an air cushion, but first let's just talk about the weight. You've got a lever and a weight, and once again, the weight is just like the spring where it's stored energy. And when the valve is open, the weight is up, but it's actually exerting slightly less force on it than when the valve is nearly closed. But the weight is up, and when the flow goes away, the weight will bring the valve closed quicker than normal. Now, how do you adjust the amount of speed? How do you adjust the speed at which the valve closes? Well, like the spring, you can adjust the length of the spring. With the weight, you can move it further out towards the end of the shaft, or further in, away from the shaft, or further in towards the shaft. And the idea with moving that weight is it gives you different amounts of leverage. When it's when it's all the way out, you have the greatest amount of leverage, and it actually will close the valve the fastest. When the weight is all the way in, it'll let the valve close a little bit slower. Now, why don't we just leave the weight out all the time? Well, that's not optimum. You know, if you get the valve, especially on bigger valves, you get the valve to close rather quickly. Even though you're not slamming the valve, you still might be driving that door into the body real quick, real fast, and you could cause some forces that could cause damage to the valve either right away or over time. So we ship the valves with the weight in the mid position. And right in our instruction manual, we do advise to adjust the weight out only if the valve isn't closing quick enough. Don't just put it out there automatically. So, you know, the weight can't, like I say, the weight can be adjusted out all the way, and it can cause the valve to close rather quickly, causing in the disc. I call it the slap into the seat because it's not the same thing as slam. Now, we're showing this valve equipped with the air cushion, a popular option. And the idea is when the valve opens, it's gonna come close quickly if you got the weight out there. But you don't want it to hit the disc body that hard. And I like to compare this to, for those that live in environments where there's mosquitoes and warm weather, like Minnesota, think of a screen door in your house. And when you first put the screen door in your house, it's swinging in the wind. You might even have a spring on it to help close it fast. You know, every time the kids run out of the house, they let go of the screen door and it slams into the jamb. Well, it may not hurt anything, but it sure is annoying. Or it might loosen the jambs over time. So what do? You go down to the hardware store and you buy a door closer. And the way a door closer works is it lets the door come nearly closed and then it catches the door and eases it into the. That's exactly what an air cushion does. And no, show it. And so it lets the valve come closed, and it can be adjusted differently. A lot of times you'll see it where the valve is nearly closed and the air cushion just catches it right at the end and gives it a soft landing or a pillow. So I want to, it does protect the valve, but I want to be perfectly clear about one point. Putting an air cushion on a swing check valve is not a way to prevent slamming. The way you prevent slamming when you have a lever or a spring and weight, lever and weight or a lever and spring, is you adjust the weight or spring enough so that the valve closes before flow reversal. If the valve didn't get closed in time, the air cushion does not have stiff enough resistance to prevent the forces of flow reversal to prevent the valve from slamming. Just like that storm door, you can still grab the storm door and still slam it shut even though there's a spring closer on it. So it does not prevent slamming. The adjustment of the weight or the spring is what prevents slamming. We also offer a lever and weight with oil cushion closure device. The oil cushion is a fully adjustable engineered shock absorber. It is designed to absorb the impact forces during valve closure. The oil cushion helps minimize the rebound or bounce of the lever arm to reduce mechanical fatigue of critical components. You cannot always prevent slamming. Sometimes you can't get the valve closed fast enough. It just can't happen. You've adjusted the weights, you've adjusted the spring, and you still have flow reversal. That's quicker than when you get the valve closed. In that situation, the flow will catch a disc and it will slam hard into the body. Sometimes it might just be a loud noise, might be annoying, but it might be worse. You could cause hydraulic shocks in the system that cause the pipe to vibrate, hangers can come loose, supports can move, and so forth. So it can be a problem. You can even cause some types of surges. So you have to be careful if it happens to the point where it's causing those problems. Now, how do you identify slamming? Well, there's no formula that helps you determine what slamming is. So it's basically based on experience. And our experience says, look out for these things. High static heads. Anytime that the system side is higher pressure, there's potential for the flow to return quickly as well. When there's surge tanks, that's a type of a device put into downstream piping from a pump that some people use that puts water back into the pipe real quickly. When there's a downsurge, it injects water under pressure back into the pipe quickly. And that water goes up the pipe and down the pipe, and it can get right to that check valve and slam it real hard. Vertical pipe runs. Gravity can really reverse flow quickly. And there's other, more technical issues like column vacuums and so forth. So, as a salesperson, this is a sales opportunity for us. we can help solve these customers' applications, not only with a more general type lever and weight, but now with something more, you know, robust. And so we're going to flip back to the slide real quick, or to the valves real quick. Okay. First one we're going to look at is actually, this follows the same vein as the lever and weight and lever and spring, where if you try to accelerate the valve close quickly, one of our very highly specifiable features on a rubber flapper check valve is a spring return. When the valve opens, the spring compresses. When the flow goes away, the disc is forced to close because the spring accelerates it closed. And once again, trying to close it before flow reversal. The reason that this is highly specifiable by Zurich is we're the only ones that make this valve with a external adjustment. Other people put a leaf spring inside the valve, but ours has an external adjustment, and you can specify how to do that. You want to just show them or explain how it works?
Yep. So to adjust the compression on this spring for more compression or less, what you will do is you'll remove this cover. There'll be 4 bolts total. This is just the cutaway here, and you will remove this cover. Inside that cover, there will be some hex nuts in there. They'll be locked together. You'll need to loosen them up, and then you will be able to either pull this up farther for less compression, or you'll be able to drive that stud down farther, putting more preload onto the spring, getting more compression out of the spring, which will then put more downforce onto the flapper, which will help to close it a little bit quicker. So this is how you would adjust it. Everything could be in line. You could have your system running, and you could adjust the amount of compression that is onto that spring.
Right, and just to be clear, this is more like the lever and weight or lever and spring with the idea of closing the valve before flow reversal. Mm-hmm. The next we'll show on slides is that we want to show you another way that it's not only that totally prevents slamming. Okay. Okay. What you're looking at, if you can't get the valve closed quick enough before flow reversal, then you need to take control of the disc. You need to grab it and take control of it before it slams into the body. So our solution, our most recommended solution is the bottom-mounted buffer. The idea with the bottom-mounted buffer is that it has a oil-filled cylinder at the bottom of the valve. And by the way, we can do this on a rubber flapper check valve as well. The oil-filled cylinder grabs the disc during the last 10% or so of the travel, and it keeps it lets the disc in the seat slowly. And when I say slowly, I'm talking about a second or two. It doesn't take much. You just need to take off the velocity of the disc movement and ease it into the seat. It's oil filled, so it's more like a shock absorber. It's not soft like an air cushion. And you can adjust the speed accordingly, but it doesn't have to take very long at all. When the valve opens, the pressurized reservoir pushes oil into the lower part of the bottom-mounted buffer and extends a piston rod, and it's ready for the next time that the valve closes. It is the responsibility of the owner operator to check the air pressure periodically. You can see the pressure gauge on the lower reservoir, and it's important that pressure is checked periodically, and the pressure is determined by the application that the valve